Right. Hopefully you all had a relaxing 5 days. It was a little rough when the alarm went off for me this morning at 5 o'clock. I didn't realize what was going on at first. That rude awakening of an alarm going off, sleeping in the last 5 days. Everybody have a nice break. I know, it always seems so short.
It's like so short. It felt like a weekend.
Yeah,
That's where it all
it
goes.
really did. It always seems so short.
The one thing I found out is that Brewster's sells good lemon sherbet. It tastes like
Oh, we should go get the sherbet. They're supposed to have a new, I think the flavor of the month is like caramel macchiato.
yeah, something like that.
Yeah,
But
that
the lemon one tastes
sounds really
like
good.
lemonade. It tastes so good.
I could see my daughter getting that option. We haven't been to Brewster's for a while. Nice. And the weather has been gorgeous, so time to go to Brewster's for sure. All week looks nice. What a nice week to be outside after school. So today we are starting the second half of the chapter. Your tests are graded. I literally just realized that I didn't have the score in Power School, but they've been graded. So I will put that score in Power School. You can check out your score. They were really good. So that was a really good first large grade for the fourth marking period. They were definitely very, very good tests. So I will place those scores in Power School. They were graded last Wednesday, but after Wednesday, I kind of like shut down from school mode. So just never got them into Power School. They've been graded. Today we're starting like the last algebraic push of the class. And this I think is probably my favorite portion of the chapter, maybe even of the year to do, because of the reliance on algebra, factoring all of the concepts we've been using. Thank you. This is like the big culminating, pulling everything together from the entire year portion of what we're going to be covering algebraically. After this, we are totally going to kind of change gears and end the year with probability statistics and a little bit of series and sequences. So this will be our last big algebraic portion of the class, but it kind of ends the algebraic part pretty nicely because it pulls together everything we've been discussing. So we will be doing a lot of factoring and using concepts that we have been working on all year, which is the way it should go in math, because it kind of math does build and rely on previous concepts discussed. So we're going to look at something called simplifying rational expressions today. We've been graphing rational functions, all of those crazy graphs. A change of an exponent creates a new and different graph. So instead of graphing them, we're going to see if we can work with their expressions and, of course, eventually solve the equations. One of the main goals of algebra is to solve for x. And now we've looked at so many different equations and ways to solve for x. So we will get there by the end of the chapter. So in your packet, we are looking at section 8.4. I will say that this second part, until we get to, I think, section 8.6, I have worksheets every day instead of book homework. I didn't really like the book problems, except for the last section. So worksheets every day that I pretty much created myself. They're a little better than some of the book problems. So today we are going to talk about multiplying and dividing rational expressions. So we know how to multiply and divide, but what does it mean to multiply and divide a rational expression? Part of multiplying and dividing rational expressions is to make sure that our expressions are in simplified form. So let's just talk about an expression being in simplified form. So from chapter 1, that's when we started working with expressions at the very beginning of the year. What does it mean for something to be simplified? So an expression to be simplified. So think 2x squared plus 3x plus 5x squared minus 7x. What would I have to try and do to simplify? Eva? Take a GCF out. What else can we do to simplify? That would be one thing to do. Combine like terms, pull everything together. So simplified form usually means the broken down form. How simple can I get it? How can I pull things together? When we're talking about rational expressions, remember rational expressions are fractions. Every equation we graphed was a fraction. So simplified form of rational expressions, turn my pen on, is when the numerator and denominator have no common factors. So we will have to pull out a GCF if there is a GCF in common, because we're going to have to look at factors. Simplified form of a rational expression means the numerator and the denominator should have no common factors. Remember, factoring is when you break the problem down and you place it in parentheses because it should become a multiplication problem when it's factored. So there is a property dealing with simplifying rational expressions. And this property says let A, B, and C be non-real numbers, or non-zero numbers, not non-real numbers, or variable expressions. So they could be numbers, they could be expressions containing variables. Then the following property applies. So this property says if I take A times C divided by B times C, what do you think that would become? Jaden, A times C divided by B times C, what would that become?
Would it be 1, 0, 1?
What terms would cancel from this?
Oh, okay. Would it be A over B?
Yeah, it's going to be A over B. Our C term is the part that's in common. That's going to be the factor that we cancel out from the problem, from the numerator and the denominator. And you're left with just A over B, not C. But the key thing here is that this must be a product. And usually it's going to be a product of factors. If it's not a product, you cannot cancel. So if I had 2 plus 3 divided by 2 plus 5, that isn't a product. That's an addition problem. I would be finding the sum. I cannot cancel the 2's when it's a sum because that's not a property. That would become 3/5, where my answer is supposed to be 5/7 because a product means you're supposed to add. I'm sorry, a sum means you're supposed to add. A product means you're supposed to multiply. So this property only works when it's a product in the numerator and the denominator. So on the side, we're going to talk about a couple little steps. And the first step is the most important. You must factor. And we must factor both the numerator and the denominator. Factoring makes expressions become products. That's how I can take an addition problem and make it multiplication by factoring. And it must be multiplication for us to cancel or reduce, simplify the expression. The second step is going to be to cancel the common factors. Or I'm going to say quantities. So step one, the biggest, most important step here. It must be factored so that it becomes multiplication. We have to have a product in order to cancel common factors. Once we have a product, then you're canceling any common factors to simplify and reduce so that it is in simplest form. So if you look at the three problems here, you can see that we have a lot of variables. The first one in part A looks like something we would have graphed in those 2 weeks of graphing rational equations. We have x squared plus 7x plus 10 over x squared minus 4. The top, the numerator, is a different type of factoring than the denominator. So we're going to cover all of the types of factoring that we would have gone over. The top is a trinomial. And we've been factoring trinomials. Brooke, how would you factor the numerator here? X squared plus 7x plus 10. What are you looking for? Yeah, we're going to use AC method. Two numbers that multiply to be 10 are 2 and 5. And when you add them together, you get a 7. So the coefficient is a 1. This is the basic AC method. Take those two factors, plug them in parentheses. Jordan, x squared minus 4. What type of factoring is that? Yeah, they are perfect squares, and it's a difference of perfect squares. So Jordan, how would that factor?
X minus 2.
Perfect. So we took an expression that was being added in the numerator, subtracted in the denominator, and we changed it to a product by factoring. The second step is to cancel any common factors. So Riley, do you see any factors that are the same?
X plus 2.
Yeah, the x plus 2. So because you're multiplying by the property above, you're allowed to cancel common factors, whatever part's the same. They cancel. And then the remaining expression, x plus 5 over x minus 2. That's our remaining expression. What factors are left? Now, here's the part where some of you really want to cancel this further because there are x's here. Can you cancel those x's and just make it 5 over negative 2? Jordan, why not?
Because it's not product.
Right, it's not a product. And it doesn't work when it's a sum because the expression isn't equivalent. Remember, x is the variable. I can place anything in there. So that's going to make my top value different than the bottom if I cancel those out. So my simplified expression is still an expression. An expression has variables, has addition, subtraction, variables remaining, is now simplified. So let's look at part B, try it again. Simplify the expression. So think about the type of factoring you need to use. Ella, what do you notice about the numerator in this problem? Yeah, this one has a GCF. What can we take out? What else could you take out? Yeah, we could take a 4, an X, and a Y. So looking at the numbers and then look at each individual variable. Remember, when you're pulling a GCF out, you're really dividing. Factoring is breaking down or dividing into a product. So we now have 2 and an X, 3 and a Y. And I take out the 4XY. All right, Grace, how about the denominator here?
Well, 6x squared y. And then 2x.
Yeah. So if you're taking a GCF out, you're probably going to be able to cancel that factor remaining. And if you look, taking out the GCF, we have 2x plus 3y. So that quantity is the same. The factor is the same, so it cancels. So what we have left is 4xy over 6x squared y. Is this still a product? Yes, we're still multiplying. We have 4 times x times y divided by 6 times x squared times y. So now if you go back to chapters 5 and 6, we simplified rational expressions in chapter 5 and 6 as well, using all of those properties of exponents. So Grace, how could we continue to simplify this?
the 2/3. It's about 1x and 1y.
Yeah.
1x and 1.
Excellent. So she used a good word. The 4 and 6 reduce. The x in the numerator is totally gone. The x in the denominator, there were 2 and it becomes 1. So the y's canceled. We reduce the x's, 2 on the bottom, 1 taken away from it. And then the numbers 2/3 reduce. So the 2 still stays in the numerator. And now this is our simplified expression. Nothing else is in common for us to reduce. All right, one more of these. X squared minus 4x minus 5 over x squared plus 5x plus 4. So again, factor first. It must be in factored form for us to simplify. Cody, how would our numerator factor? So we're looking at a -5. We want to make a -4. And then how about the denominator, Cody? We have a 4 and we want to make it a +5. But x plus 4 and x plus 1. You were on the right track there. And then Cody, any common factors? Yeah, the x plus 1. So they cancel out. And we have an x minus 5 over x plus 4. Again, don't get simplify happy here. Don't want to go cancel crazy. This is now a subtraction. This is the difference. This is an addition. So I have sum, no longer a product. It cannot cancel. Any questions? So multiplying and dividing are essentially the same exact thing, except instead of having one expression, which means one fraction, you have 2 because you're multiplying one thing by another. So one rational expression by another rational expression. So again, we have a little rule for multiplying. Let A, B, C, and D be non-zero real numbers or variable expressions. The rule for multiplying rational expressions is the same as the rule for multiplying numerical fractions. So if I multiply 1/2 times 3/4, it's the same thing as multiplying these 2 expressions together. So you multiply the numerators and then you multiply the denominators. So essentially you're going across the top and across the bottom to multiply. Top times top, bottom times bottom. That's how you multiply fractions. And then it says write the new fraction in simplified form. So if I look, my little property here, I'm multiplying across and I would get A times C. And then I'm multiplying across the denominator and I would get B times D. So top times top, bottoms times bottom, whatever numbers they happen to be. It does say to simplify if possible. So if I can simplify, we want to make sure that it is simplified because it is a product once I multiply 2 expressions together. So the steps here are typed out for you. Again, the first step, factor. You're going to hear me say that, factor first, factor first, factor first. Before you do anything, you must factor. The second step, divide out any common factors and simplify. So we're actually going to do the simplifying before we do the multiplication. And then the last step, multiply any remaining terms. All right, let's look at this one here. Part A, you have 2 expressions, rational expressions that you're now multiplying. So factor first. What can you factor out? Is there a GCF or is there a type of factoring that you can do? So see if you can get these to factor. There's 4 of them. I now have 2 numerators, 2 denominators. Factor. By the end of next week, factoring will be your new best friend. It is one of the most basic algebraic methods besides like getting exponents self-isolating. Factoring is kind of the foundation of so many different processes, algebraic processes, pre-calc, calculus, like factoring is kind of the foundation of all those. All right, Ava, what'd you do with the numerator on the left?
I took out 5x. And then it was 4 minus x.
And then how about that denominator?
I took out that.
Still have a multiplication symbol because we have two fractions. How about the second fraction, Ava?
-4, so -1 plus -1.
Okay, x minus 1. It's a positive 4 because we have a positive 3. So we said -1 plus 4. And then the denominator there? Mm-hmm. Nice job. All right, everything is being multiplied. Even the expression is being multiplied. There's a little time sign here. So we can cancel the x plus 4s because that's the same factor. So we can cancel those out. However, you can continue to cancel the x minus 1 with the x minus 1 in the denominator of the first fraction. This is being multiplied. So anything in the numerator can cancel with anything in the denominator. Multiplication is commutative. So division is also commutative. I can kind of divide here and cancel with something on the opposite fraction. So they're going to cancel. If you look at that first numerator on the left, we have 5x and then it says 4 minus x. If I look at the denominator on the right, I have an x minus 4. They're really close. They're exact opposites. 4 minus x, x minus 4. I can't cancel them because they're not the same. But if you look at the GCF, we took out a 5x. What do you think we could take out instead of a 5x to make them identical? So I want to make this 4 minus x on the top left to be exactly the same as x minus 4. Ella? Yeah, let's try taking out a negative 5x. If we notice, this 5x squared is a negative 5x squared. Let's make that a positive 5x squared by taking out a negative 5x. So Ella, if you take out a negative 5x, what does that then make your factor? Yeah, so it makes it a negative 4 and a positive x. So it's going to switch the signs by taking out a negative. And I wrote it so that the x is in front and the 4 is in back. Now we can cancel out the x minus 4. Oh yeah, yes, yep. So if you wrote it as -4 plus x, you can still cancel them because they're both -4, they're both positive x. So what we have left is the negative 5x over x. Gabby, anything else? Gabby Soul? You can simplify this just to be -5 because now my x's cancel as well. These are kind of nice because you start out with a big problem and then a whole bunch of stuff cancels and you get a -5 as an answer. So it starts out really big, but because of factors being in common of the numerator and the denominator, they can all cancel out. So why don't you try the one right next to it? See if you can get them to factor and cancel, simplify, but factor first. So our problems could start off looking really huge and involved, and you end up getting a nice simple answer, maybe just a -5. Remember, you can cancel until your expression remaining is addition or subtraction, and then the canceling is done. Aline, can you factor the first fraction numerator denominator? Okay, what'd you get? Good. Did you factor anything else? And what'd you get there? So both of those are that AC method, just AC, regular basic AC method. What about that first numerator, 2x squared plus 4x? Julia, what could you do with that? Yeah, we could take out a 2x, that's a GCF. What's left when you take that out? X plus 2, yeah. And then cancel away. So now that it's factored, x plus 2 can cancel. The x minus 6, it's allowed to cancel as well, as long as one is in the numerator and the other one is in the denominator. Can anything else cancel? Gabby Snyder, do you see anything else that we can cancel? Yeah. What are you left with? So when you're done, look across and see what remains. So the only thing in the numerator is an x minus 3. Nothing is left with the denominator. They all cancel out. Question. Say it again. So if I write what we have left, so whoops. We have right now a 2x times a 2x minus 3. So if I write that out, I have 2x times can be multiplication, so x minus 3. So now I'm trying to pull that together in one fraction. On the bottom, we still have a 2x. That's the only thing left in the denominator. It's still multiplication in between these two. So because this is still multiplication here, I'm not canceling out the x minus 3, that's subtraction, but 2 times x is being multiplied. And that's by itself, being multiplied with just itself. So we can cancel those because it is still multiplication. Good question. Any other questions? All right, so if you look at the next page, oh, today's picture day. That's why everybody looks so lovely. Picture day. Forgot about that. We are going to skip the independent practice and we are going to go down to example 3. We're going to continue to multiply, and then the last thing we do, it says, is divide. Multiply a rational expression by a polynomial. So this takes what we did in chapter 5 and our functions in chapter 8 and pulls them together. So we have a rational expression. That's this part on the left. Rational expression is a fraction. You're multiplying it by a polynomial, which is in parentheses. It's not a fraction, but we can always make anything a fraction by placing it over 1. So that at least appears to be a fraction. Now, here's going to be the challenging part. The factoring we've done so far has been basic factoring that we've been practicing a lot in chapter 6 and 7, and even in 8 to get those x-intercepts or to find the asymptotes. This denominator has x cubed plus 1. It's not a squared, it's a cube. From chapter 5, we factored perfect cubes. And there was patterns or formulas that we used to factor. One for it being a sum, which is what we have, and the other one for it being a difference. That pattern for the sum is a plus b, a squared minus ab plus b squared. The pattern for the difference is a minus b, a squared plus ab plus b squared. Notice that the variables are the same. I have an a and a b, I have an a squared, an a times b, and a b squared. The signs, the symbols in between are the part that changes. And we called this the SOAP formula. SOAP meaning S is the same sign. So if I start with a plus, I should have a plus in my first factor, or if I start with a minus, I have a minus. O being the opposite sign, opposite of what you start with, and AP being always positive. Notice that they both end with a plus sign. So same sign, opposite sign, always positive. So we call this the SOAP formula for factoring. A, same sign B, A squared, opposite sign, AB, always positive, B squared. So we're going to factor this. The first numerator, x minus 4, cannot factor, it's linear, it just stays as x minus 4. The denominator is the cube part, and it's a plus. The a term is the cube root of x cubed. Well, what's the cube root of x cubed? Just x. The b term is the cube root of 1. Well, the cube root of 1 is just 1. So when you factor this, you have a, which is x. Same sign. I start with a plus, so I have a plus. And then b is 1. Make my fraction bar a little longer here. And then it says take a squared. Well, that's x squared. The opposite sign, I started with a plus, so now it's a minus. A times b, x times 1 is just x. And then plus b squared, which is plus 1. When you look at that denominator, that is now factored as a perfect cube. That was a special form of factoring from chapter 5. Jaden, what do you notice about the numerator of the second fraction?
It's the same exact as the one that we got the denominator.
Isn't that a nice coincidence? So if you notice, the second fraction's numerator is the same as the factor that we just found by using the perfect cube formula. Jaden, what do you think happens with that?
Would it cancel out?
Yeah, it's going to cancel out. That whole quantity is the same. So they cancel. And then we have an x minus 4 and an x plus 1. And that's it. X minus 4, x plus 1. Questions? So we're going to go down underneath and we're going to look at the final part, which is division. Division is really the inverse of multiplication, but to divide fractions, you change it to multiplication. And you multiply by the reciprocal of the fraction that follows the division sign. And then we still multiply them together as we did with multiplication. So division is really multiplication by the reciprocal of the second fraction. So our steps over here, the first step is to change it to multiplication. By taking the reciprocal of the fraction after the division sign. And then we just follow the steps of multiplication. So we change it to multiplication by taking the reciprocal of the fraction after the division sign. And then we follow the steps for multiplication, which means I have to factor, and then I cancel, and then whatever is left gets multiplied together. So the directions, for example, for the last example here, say to divide the following rational expression. In order to divide, you need to multiply by the reciprocal of the second fraction or whatever follows, you're welcome, the division sign. So if I look here, I have a 3 over x plus 7. That's not changing. That's going to remain the same. It's going to be 3 over x plus 7. You're taking the reciprocal of the fraction that follows the division sign. And the reciprocal means whatever was on the bottom comes to the top. Whatever was on the top moves to the bottom. Now I follow all the steps of multiplication, which means I have to factor. Well, 3 over x plus 7 doesn't factor, but that second one does. So I would have a plus 7 and a minus 1. I take out an 8x, I end up with an x minus 1. So make it multiplication by taking the reciprocal of the fraction following the division. Once you multiply, we factor and cancel. And then we have a 3 and an 8x remaining. So your homework, as I said, is a worksheet posted to Google Classroom with an answer key. Please check those answers. Fill out the homework question form if you have any problems that you cannot factor. Have a great day.